Hello student. So let us start our discussion. So in this tutorial we will try to discuss what is space-time diagram, and then we will discuss speed-up ratio, means ratio of non-pipeline system to pipeline system, so that we will see that what will be the speed improvement whenever we will try to utilize the pipeline system. So before starting that discussion, let me tell you that what is space-time diagram. So here let me write down all the segments so you can have idea that this is segment 1, this is segment 2, this is segment 3, this is segment 4. Okay, clear? So this segment are the segment of pipeline which we have discussed previously. Here we will write down the clock. So clock 1, clock 2, 3, 4, 5, 6, 7, 8, 9, 10, likewise. So at first clock cycle, T1 will be into the segment 1. At next clock cycle, T1 will enter into segment 2 while T2 will enter into the first segment. At next clock cycle, T1 will be in third segment, T2 will be in second segment, and T3 will be here. Okay, next clock cycle, T1 will be in last stage, T2 will be here, segment 3, T3 will be in segment 2, and T4 will enter. Okay, next clock cycle, so T5, then T4, then T3, T2, next clock cycle, T6, T5, T4, T3, next clock cycle, T6, T5, T4, next clock cycle, T6, T5, and next clock cycle, T6. Okay, so as you can see in the figure, if you are going with the non-pipeline system, then maximum maximum time will be required. Let's say each instruction take 4 seconds, then 6 into 4, 24. Okay, and if you are going with the pipeline system, let us assume that each segment is taking 1 second, then for completing 6 tasks we will require only 9 seconds. So this is how pipeline system will be helpful in executing the instruction or parallel or achieving the parallelism in uniprocessor system. So now we will try to calculate the speed up ratio. Okay, so what is speed up ratio and what is what will be the effect or what will be the value of that speed up ratio. So let's say if you are having a non-pipeline system, okay, and each task require n second, clear? And suppose we are having t number of tasks. Okay, so let's assume that we are having n task. So T1, T2, T3, T4. Okay, so if you want to find out the time which is required to perform the n operation, okay, non-pipeline system, for each task required n second, and let's say we are having n tasks. So at that time, the time required for non-pipeline system will be ntn. Here this is the time required for each let's say instruction, and this is the instruction total number of instruction. Now if we go with the pipeline system, then initially means all the pipeline is filled. Okay, at up to that time only there will be empty pipeline. Okay, means as you can see here, let's say here we are having 4 segment, then up to 4 segment means up to step number 3 only this pipeline will be partially empty, while in step number or in timing signal number 4 you can see that pipeline is completely filled. So then onwards, for each second we will get one output. Okay, So if we are having k segment pipeline, okay, k number of segment in pipeline, okay, and TP means time required by pipeline system to execute n task, okay, then first task t1 require time equal to ktp, okay. So for first task only we will require ktp. For the remaining all tasks we will get output into n minus 1 tp. Clear? Okay, why? Because after that onwards, means after execution of first instruction, remaining all instruction will be executed in 1 second. Okay, here as you can see, after third second, means after third second onwards, fourth second we are getting one instruction, fifth second we are getting one instruction as output, 6 second instruction three is over, 7 second t4 is over. So means uh, for initial condition where pipeline is partially empty, then only we have to wait, okay. Then onwards for each second we will get one instruction completed, okay. So for that n minus 1 tp, okay. So it will be like k plus k into tp plus n minus 1 into tp, okay. So if we take common tp, if we take tp common, then k plus n minus 1 into tp. Clear? And what is speed up ratio? So the speed up ratio is ntn, means ratio non pipeline system to pipeline system, k plus n minus 1 tp. Okay, clear with this? Okay, so let's try to calculate a numerical, okay. So let's take one value. Let's say we are having 4 segment pipeline, so value of k will be 4, okay. And then let's say each segment in pipeline require 20 nanosecond to complete the task, okay. And let us assume that we are having 100 tasks, okay. So if we put all this value into equation, then 4 plus 100 minus 199 into 20, okay. So we will get 2060 nanosecond, okay. Now let us assume that in non-pipeline system there are similar the non-pipeline system is similar to this pipeline system, but there won't be different segments. So 20 into 4, so for non-pipeline system let us assume that for each task we required 80 nanosecond. Why? Because if we consider that all the segments which are present in pipeline, they are also present in non-pipeline, but there are not different segment, means all will work as a single unit, okay. Then to complete one task we require 80 nanosecond, and same way we are having 100 task, then total amount of time required will be 8000 nanosecond, okay. So if we if we find out the speed up ratio, then tn by tp, then tn is 8000 and tp is 2060, okay. tn means non-pipeline system and tp means pipeline system. So this value, this ratio we will get will be 3.88. so what we can say that here we can say that pipeline system is almost 4 times faster compared to non-pipeline system. Clear with this? Okay, so next question would be that what should be the total number of segment? So that will be also obvious question. So larger number of segment, then we will have a higher degree of parallel execution, okay. So that will be the advantage, but what will be the downside? If the number of segments are getting larger, then design of control unit will be very difficult to implement, okay. Why? Because we have to maintain the synchronization between segment. So what will be the problem in pipeline system, okay. So till now we have assumed that, let's say if we are having segment 2, segment 1, segment 2, segment 3, and segment 4. Okay, then let's say we have assumed that if segment 1 is taking 20, then 2 will also take 20, 3 will also take 20, and 4 will also take 20. But in real life scenario, it is not like that. Okay, so it may be like that segment 1 will complete task in 20, this will complete task in segment 1 will complete in 10, segment 2 will complete in 20, segment 3 will complete it in, let's say, 5 seconds, and segment 4 will complete in 1 second. So in that case, what will happen, that segment 2 will get double speed output with a double speed. Why? Because while segment 2 will complete one task, meanwhile segment 1 will complete two tasks. Okay, so which is not good. So segment 1 has to forward the result, and then it has to wait for 10 seconds. Clear? So 10 plus 10, 20. So then and then means here we have to add delay of 10 seconds. So then and then next instruction will be fetch and it will be forwarded. Here what will happen, here this is taking 20 seconds. Okay, and this segment is completing the task in 5 seconds. So this segment 3 has to wait 15 seconds till the input is there from the segment 2, and this is completing in let's say 1 second, and this is completing in 5, so this has to wait for 4 seconds. So as you can see, here we have not considered the delay from first element or first segment to last segment. We have tried to consider only individual delay. Okay, so it will be very difficult to implement. So the theoretical ratio which we are getting for theoretical speed up ratio which we are getting, okay, it is not possible that practically we will get the same ratio. Why? Because here in pipeline system we have seen that there will be intermediate register, so it will also take some time to forward the data from one register, in segment to register and register to segment, while in case of non-pipeline system there won't be any intermediate element, so data will be forwarded faster. So definitely while we are getting the speed, there will be also some downside, and we have to consider accordingly that what should be the number of segment into the pipeline. So in this video we will keep up to this. In next video we will go with the arithmetic pipeline. Okay, so we will try to discuss that how arithmetic operations are implemented using pipeline. Thank you.